What if I told you that everything you are, everything you've ever known, all began in the heart of a cosmic explosion 13.8 billion years ago? In an instant, the universe was born, and with it, the very building blocks of life: hydrogen, helium, and stardust, materials that would one day become you. This isn't just the story of the universe, it's the story of us. From stardust, to cells, to consciousness. Today, we embark on a scientific journey that spans billions of years, tracing the cosmic origins of life. And ultimately, the evolution of the human species. I am Dr. Physicist, and today we are going to decode the greatest story ever known, the story of how Stardust became Homo Sapiens. $13.8 billion years ago, time and space came into existence in an instant. The universe, once smaller than an atom, exploded in what we now call the Big Bang, the most colossal event in the history of everything. From this singularity, all matter, energy, space, and time began to unfurl. This is the beginning of a journey that leads, eventually, to you, to Homo Sapiens. In the earliest moments, the universe was a searing hot soup of subatomic particles, a plasma so dense, not even light could escape. Just minutes after the Big Bang, the universe was hot and dense enough for nuclear reactions to occur between these subatomic particles. As the universe expanded, it cooled down and these particles bonded to form the simplest elements: hydrogen, helium, and a trace of lithium. This epoch, known as recombination, occurred roughly 380,000 years after the Big Bang. It allowed the universe to become transparent, enabling light to travel freely across the cosmos. The cosmic microwave background radiation, which we still detect today, is a relic of this time, a snapshot of the universe when it was still in its infancy. As hydrogen and helium filled the vastness of space, gravity began to take over. Under its relentless pull, vast clouds of gas collapsed in on themselves, igniting the first stars. These stars burned with ferocity, fusing hydrogen into heavier elements like carbon and oxygen in their cores. But stars are not eternal. When these first giants reached the end of their lives, they exploded in supernovae, scattering their elemental riches, iron, carbon, nitrogen, across the cosmos. These elements, formed in the hearts of stars, would one day give birth to planets and life. With the formation of the other major elements of our periodic table. Around 4.5 billion years ago, in a spiral arm of the Milky Way, one such cloud of gas and dust collapsed, forming our Sun at its center. Around the Sun, remaining material coalesced into planets and our solar system is formed, in which all planets are rotating around the Sun, including a small, rocky world we call Earth. At first, Earth was a violent place. Asteroids and comets pummeled its surface in a period known as the Late Heavy Bombardment. But this chaos also delivered to Earth the water, which will be essential for all life on Earth, supporting ecosystems, regulating climate, and enabling vital biological processes. $4.2 million years ago. Earth was a volatile and hostile environment characterized by intense volcanic activity, frequent lightning strikes, and high levels of ultraviolet radiation. The primordial phase of Earth, preceding abiogenesis, was marked by a reducing atmosphere rich in methane, ammonia, and hydrogen, with no free oxygen. These conditions set the stage for the chemical evolution that eventually led to the emergence of life. Around 3.8 billion years ago, life began to stir in Earth's primordial oceans. In deep-sea hydrothermal vents and shallow pools, simple molecules combined to form the first building blocks of life: amino acids, fatty acids, and nucleotides. Simple organic molecules combine to form complex polymers like proteins, lipids, and nucleic acids like RNA. This process was likely facilitated by surfaces such as clay, which can catalyze chemical reactions. Polymers became enclosed within lipid membranes, forming protocells. These protocells could maintain an internal environment different from their surroundings, a crucial step towards cellular life. With the formation of deoxyribonucleic acid, some protocells developed the ability to replicate themselves. RNA, which can store genetic information and catalyze chemical reactions, is thought to have played a key role in this stage. Early protocells evolved metabolic pathways to harness energy from their environment, allowing them to grow and reproduce more efficiently. The last universal common ancestor, LUCA, estimated to have appeared around 3.6 to 4.2 billion years ago, was a simple, single-celled organism with a lipid bilayer membrane and the genetic machinery necessary for protein synthesis. LUCA's significance lies in its role as the progenitor of all current life forms, providing a genetic link between the three domains of life: eukarya, archaea, and bacteria. Both archaea and bacteria are called prokaryotes as they are single-celled organisms that lack a nucleus and membrane-bound organelles. For millions of years, these prokaryotes dominated the planet. One of the earliest known life forms, cyanobacteria, would eventually change the course of Earth's history by harnessing the power of sunlight. Over 2.5 billion years ago, cyanobacteria developed the ability to photosynthesize after the evolution of chlorophyll, which converts sunlight into energy in the presence of carbon dioxide and water, along with releasing oxygen and food as a byproduct. The oxygen they produce transformed Earth's atmosphere in what is known as the Great Oxygenation Event. For many of Earth's anaerobic life forms, this was a catastrophe, a mass extinction. But for others, oxygen opened the door to new possibilities. It allowed for more efficient energy use, setting the stage for complex life. Imagine a primordial ocean teeming with simple prokaryotic life, where the first eukaryotic cells emerge, distinguished by their complex internal structures and nuclei. These pioneering cells, appearing around 2.1 billion years ago, mark a significant evolutionary leap, thriving in the oxygen-rich waters and setting the stage for more complex life forms. Around 1.5 billion years ago, the first multicellular organisms began to form in the ancient oceans, as individual cells started to cooperate and specialize. This pivotal development allowed for greater complexity and diversity in life forms, paving the way for the evolution of plants, animals, and fungi. Between 572 and 850 million years ago, the first animals, such as simple sponges and other soft-bodied organisms, began to appear in the ancient oceans. These early animals played a crucial role in shaping marine ecosystems, mixing the water and distributing nutrients, which helped pave the way for more complex life forms. The geological time scale, GTS, is a system used by geologists and other Earth scientists to describe the timing and relationships between events in Earth's history. Based on significant geological and paleontological events, such as mass extinctions and major climatic changes, it divides Earth's history into several hierarchical units. Eons, eras, periods, epochs, and ages. Eons are the largest time units, spanning hundreds of millions to billions of years. Earth's history can be divided into 4 eons: Hadean, Archean, Proterozoic, and Phanerozoic. Subdivisions of eons, lasting tens to hundreds of millions of years, are called eras. The Phanerozoic eon has 3 eras: Paleozoic era, Mesozoic era, and Cenozoic era. Subdivisions of eras, lasting tens of millions of years. Geologists divided the Paleozoic era into 6 periods. And first period is known as the Cambrian period, which existed between 541 to 485.4 million years ago. Fast forward to 541 million years ago, and Earth witnessed an unprecedented explosion of life. The Cambrian explosion gave rise to a dazzling array of creatures, including the ancestors of nearly all modern animal groups. For the first time, animals developed hard shells, eyes, and segmented bodies. The evolution of vision, particularly the ability to detect light, is a fascinating aspect of life's history. Vision likely began with simple light-sensitive cells that could distinguish between light and dark. During this period, early vertebrates appeared, and ecosystems became more complex. At about 500 million years ago, the fungi started taking over the land. And about 470 million years ago, plants began colonization of lands. Life was flourishing in the oceans, but it would take millions more years before life took its first steps onto land. About 375 million years ago, fish-like creatures began to evolve limbs and lungs, enabling them to explore land. These pioneers eventually gave rise to amphibians, reptiles, and later, the mighty dinosaurs. That would dominate Earth for over 160 million years with its all variants. At about 200 million years ago, first mammals appeared on Earth and started living with these reptiles. But even the reign of the dinosaurs was not eternal. Our Earth is not a lone traveler, it journeys through a vast and dynamic cosmic neighborhood. All around, asteroids and comets sweep through the void, each a fragment of creation left from the early days of our solar system. Some are ancient, rocky relics, wandering endlessly, while others are icy, volatile bodies hurtling in long, elliptical orbits, occasionally venturing near the warmth of our sun. Most of these celestial wanderers pass us by in silence, but not all. Every so often, Earth and an asteroid cross paths in a cosmic rendezvous governed by gravity and chance. We've been struck before, leaving craters as scars of past encounters. Some of these impacts have changed the very course of life on Earth. 66 million years ago, a catastrophic event wiped out 75% of all species on Earth, including the dinosaurs. A 6-mile-wide asteroid struck the Yucatan Peninsula, triggering fires, massive tsunamis, and plunging Earth into darkness. And as the skies burned and the Earth trembled, the reign of the dinosaurs ended, not in a slow fade, but in the violent punctuation of an asteroid's wrath, reminder that even the mightiest can fall to the universe's indifference. 66 million years ago, the age of dinosaurs met its cataclysmic end, marking the close of the Mesozoic era. From the ashes of extinction rose a new chapter in Earth's history, the dawn of the Cenozoic era. The Cenozoic era unfolds in 3 epic periods, each a masterpiece of time, branching into several epochs that shaped the destiny of life on Earth. The Cretaceous-Paleogene extinction was one of the most devastating events in Earth's history, but it also cleared the way for the rise of a new class of animals. The Mammals. After the fall of the dinosaurs, mammals flourished, paving the way for a new chapter in Earth's history. In the shadow of extinction, mammals, small, adaptable survivors, emerged from their burrows into a world ripe with opportunity. Freed from competition with towering reptiles, mammals diversified rapidly. They grew larger, evolved into myriad forms, and began to dominate ecosystems. Among them were the earliest primates, tiny, tree-dwelling creatures with sharp minds and grasping hands that would eventually give rise to monkeys, apes, and humans. Around 55 million years ago, primates evolved. These agile pioneers thrived in forests, developing forward-facing eyes for depth perception and larger brains for problem-solving. Over millions of years, primates spread and evolved, giving rise to monkeys, apes, and eventually, the first humans. From the ashes of the dinosaurs to the dawn of humanity, the story of mammals and primates is one of resilience, adaptation, and the incredible power of evolution. About 23 million years ago, in Africa, Europe and Asia. During the Cenozoic era's Miocene epoch, the common ancestor of humans and apes, Dryopithecus, appeared. They were about 4 feet tall, had a monkey-like body shape. With a cranial cavity volume of about 400 cubic centimeters, Dryopithecus likely predominantly ate fruits and soft leaves and could use tools. Between 16 to 5 million years ago, in Siwalik Hills of northern India and Kutch of West India, more man-like Ramapithecus appeared. They were about 4.9 feet tall. Limb properties indicate characteristics associated with upright walking. Ramapithecus could eat fruits with their advanced dental structure, which had thick enamel, and a combination of primitive and advanced dental features. They walked on the ground, lived in trees and could climb mountains. About 4.2 million years ago, a new group of species started walking from East Africa to Southeast Africa. During Pliocene epoch, Australopithecus afarensis appeared. They can use tools more accurately. Some of them were frugivores, while others were omnivores. They hunted animals and birds. During the early Pleistocene epoch and late Pliocene epoch, suddenly Dryopithecus from all over the world disappeared. After the disappearance of Dryopithecus, 2 million years ago, a new species Homo habilis and 1.7 million years ago, Homo erectus appeared on Earth. After the appearance of these two species, at about 1.4 million years ago, the Australopithecus disappeared from Earth. During the Pleistocene epoch, about 2 million years ago, the genus Homo appeared, with Homo habilis, the handy man, being the first known species to use tools. This marked the beginning of a technological revolution. They could usually make weapons from stone and lived in small groups. 1.4 million years ago, Homo habilis disappeared from the Earth. About 1.7 million years ago, Homo erectus evolved in East Africa. Homo erectus mastered fire, allowing them to cook food, stay warm, and fend off predators. They became one of the first species to spread beyond Africa and explore new territories, migrating into Asia and Europe. This early humans were adaptable, innovative and resourceful, laying the foundation for the emergence of a new, more advanced species, Homo sapiens. About 0.11 million years ago, the last of the Homo erectus lost existence on Earth. And 400,000 years ago, a new species started taking over Europe. The Homo Neanderthals. Around 300,000 years ago, Homo sapiens, modern humans, emerged in East Africa. When our world already had the different species of Homo. Both Homo sapiens and Homo erectus existed in East Africa at the same time. Around 110,000 years ago, during the late Pleistocene epoch's last glacial period, Ice Age started. Everything in the world started freezing. During this time, large ice sheets covered much of the northern hemisphere. The ice sheets in the northern hemisphere caused sea level to drop by 20 to 30 meters. During this time, Homo sapiens encountered Homo erectus and other species and become one of the reason of their extinction. After the extinction of other Homo families during Ice Age, the Homo sapiens started becoming the most dominant species on Earth. They could use weapons, they usually lived together in caves, they were skilled in making cave paintings, evidence of which we still find. Gradually, they began to form groups and started working together to meet their needs. About 70,000 years ago, Homo sapiens began one of the greatest journeys in the history, the migration out of Africa. As they ventured into new environments, their adaptability became their greatest strength. About 45,000 years ago, they reached Europe. And never stopped exploring. Neanderthals, who lived in Europe and parts of Asia, were a robust and adaptable branch of the human lineage. These archaic humans thrived in the challenging environments of the Ice Age, demonstrating remarkable reliance and ingenuity. They were skilled hunters, had sophisticated tools, and evidence suggests they even had rituals and possibly a form of language. Despite their capabilities, about 40,000 years ago, Neanderthals vanished. Their extinction was likely the result of a combination of factors, including competition with Homo sapiens, climate changes during the Ice Age, and possibly even interbreeding and assimilation. Homo sapiens never stopped again. They reached Asia, then Australia, North America, and finally South America. They faced new challenges, from the freezing tundras of Europe to the tropical forests of Southeast Asia. But their intelligence and social bonds allowed them to thrive. As the last Ice Age gripped the Earth, Homo sapiens faced new challenges. The landscape was harsh, with much of the northern hemisphere covered by glaciers. During this period, humans relied on their ingenuity, creating new tools, clothing, and social structures to survive the freezing conditions. When the Ice Age ended about 12,000 years ago, the world underwent a dramatic transformation. As the climate warmed, humans began to shift from a nomadic, hunter-gatherer lifestyle to settled farming communities. This was the Neolithic Revolution, the dawn of agriculture. With the advent of agriculture, humans began to settle near rivers and fertile lands. By 5,000 years ago, the first true civilizations emerged in places like Mesopotamia, Egypt, the Indus Valley, and China. These early societies developed writing, built monumental architecture, and established complex political systems. Human culture, religion, and technology began to flourish. About 500 years ago, the great scientific revolution occurred. Civilization, as we know it today, had begun. From this point, humans would create art, literature, cities, and eventually, technologies that would transform the world. From these humble beginnings, humanity has ascended to unimaginable heights. We have built cities that scrape the sky, invented technologies that connect the world, and even begun to explore the stars.
Space Shuttle Atlantis, the final visit to enhance the vision of Hubble into the deepest grandeur of our universe.
Yet, through all this advancement, we remain the product of 13.8 billion years of cosmic evolution, from Stardust to Homo Sapiens. We are creatures of the Earth, but our minds stretch to the farthest corners of the universe, pondering our origins, not only our planet but the stars themselves. As we continue to look outward, let us never forget the incredible journey that brought us here, from the atoms born in ancient stars, to the emergence of life, to the evolution of Homo sapiens. We are the product of an epic, cosmic saga that continues to unfold.
What if I told you that everything you are, everything you have ever known, all began in the heart of a cosmic explosion 13.8 billion years ago? Good. Cheers. This is not just the story of universe, it's the story of us. From stardust to cells to consciousness. Today, we embark on a scientific journey that spans billions of years, tracing the cosmic origins of life. I am Dr. Physicist, and today we are going to decode the greatest story ever told, the story how Stardust became Homo Sapiens. What if I told you that everything you are, everything you have ever known, all began in the heart of a cosmic explosion 13.8 billion years ago?